So hello everyone, very good morning. So now we are moving on to session 4 of our online atelier in e-vehicles. And this session is about hybrid electric vehicles and its performance. And this session will be delivered by Mr. Hanish KM, Assistant Professor, Department of Electrical Engineering, School of Engineering and Technology, Christ, Bengaluru. Sir has delivered session yesterday also about the revolution of e-vehicles, and today they are delivering another session here. So thank you, sir, for accepting our invitation to be part of our FTP and continuously delivering 2 sessions on the consecutive days. So we welcome you once again for our FTP, sir. So now the session will be yours, sir. Thank you.
Oh, okay. So thank you for the introduction. So welcome back all the audience. So today I'll be talking on the just share my screen. Okay, is it visible?
Yes, sir. Yes, sir. It's
Okay.
visible.
I'll make it. Okay, 1 second. Okay. Okay, so today I'll be talking on the hybrid electric vehicles and some of its performance. Okay, I think the last session for you was also on the hybrid electric vehicle. So we know Suraj. So hopefully you'd have got some good idea about what is hybrid electric vehicle. Okay, so why we are going for hybrid electric vehicle. Okay, so I'll show some performance characteristics. Okay, so the actually the hybrid you already heard and you already know. So when you are having more than one the source for the propelling your vehicle, so that is what is known as a hybrid vehicle. Okay, so generally we have the IC engine. Okay, and plus any other type of the propulsion system will be giving to the vehicle. Okay, so that is generally we'll be calling it as hybrid electric vehicle. Okay. So it can be any two sources. Okay, so it may not be IC engine and electric. So it can be fuel cell and the batteries. It can be the IC engine and fuel cell. So any combination. If more than one source is using to propel a vehicle, then we will call it as a hybrid vehicle. So that's a hybrid vehicle. So I'll be just talking on some some introduction on the hybrid vehicle. Okay, then some historical development. Okay, then some benefits of the hybrid vehicle. Then series parallel and complex hybrid. Okay, so you would have heard some of them. Okay. Now the something on torque coupling and energy management systems. Okay, then some and the simulation I will show you on the advisor and also as well as on the MATLAB simulation. So that are the contents I planned. Okay, so you know you have a vehicle to drive. Okay, so that vehicle can be a two-wheeler, three-wheeler, or a four-wheeler, or a heavy electric vehicle, heavy vehicle. Okay, or now we are trying to have even for the aircrafts. Okay, so it can be any vehicle. So basically, these vehicles we are using to the transport goods, okay, or sometimes transport passengers. Okay, so or sometimes it will be using to do some the work in the shop floor or work in the mines or some industry. Okay, so we have different types of vehicles. Okay, so sometimes we'll be using the pure electric vehicle, something like some vehicles which you are using inside the industry. Some will be using pure electric vehicle. So pure electric vehicle will use the electric motor to drive the vehicle. Okay, so you need to power the vehicle so that if you are using the electrical power, then it is a pure one. Okay, so pure electrical. Okay, but normally most of the vehicles today on road are the pure fossil fuel based or pure gasoline or petroleum based one. Okay, so either petrol engine or diesel engine vehicles we are running on the road mostly now. Okay, we have some the vehicles running with the gas. Okay, so the compressed natural gas we are using for some vehicles. Okay, but all that comes under the gasoline or which are based on the fossil fuel. Okay, so the hybrid means basically the combination of these two. Okay, so generally we are looking for the pure, I mean the some amount of fossil fuel and plus some amount of electrical. Okay, so you will have both. Okay, you have an IC engine, okay, the internal combustion engine. Okay, then you have a motor generator for driving the vehicle. Okay, then some control mechanism to control that one. Okay, and this power for the vehicle, okay, the motor will be giving from some battery. Okay, because you need to store the power, otherwise you cannot supply to the motor generator. So you'll be having some battery. Okay, then you'll be driving the transmission system, so that will be driving the vehicle. Okay, so this is the structure of a hybrid. Okay, so the you have, you know, the most of the benefits of the electrical vehicle. So yesterday we have talked on that also. Okay, so the basically we are trying to reduce the emissions. Okay, because the fossil fuel, when you are burning, you will be having a lot of the emission. Okay, and then you have the the oil price is rising. So I mean, because of all that things, we are trying to shift into the electric. And also you have a lot of the regulations, international regulation, the national wise new rules are coming. So you cannot have this much pollution. You need to implement you need to go for the new type of vehicles. You need to change emission system, all that thing. Okay, so you know the benefits of electric. So the very simple benefit is, okay, so if you are using a motor, electric motor for driving something. Okay, so the electric motor generally will be having an efficiency around 80%. Okay, or 80% and above. So if you are going for a good the induction motor and all, you'll be getting some 85-90% efficiency. Okay, but even for most of your the motors, you'll be getting more than 80% efficiency. Okay, that means whatever the energy input you are giving, so around 80% you can convert into the useful work. Okay, but whereas if you are going for an internal combustion engine, you are filling the fuel. Okay, and you are burning it. Okay, and some part of that the energy is lost in your heat. Okay, so when you are burning the fuel and that heat is generated, with that the pressure you will be using to drive the piston. Okay, so the efficiency of the internal combustion engine is very poor. Okay, so the very poor means it will be only around some 30-33% and then all. Okay, only IC engine alone. Okay, then you will be having the lot of mechanical connection from there. Then you will be having the transmission system, gears, the suspension system, wheels, all that thing. So the overall efficiency of an IC engine vehicle is very poor. Yeah. So if you are going for only IC engine, that is the internal combustion engine, petrol or diesel engine. Okay. So the overall efficiency is very poor. Okay. Whereas if you are using a pure electric, so your efficiency is quite high. Okay. So then we have a lot of constraint. Okay. So yesterday we had talked. So the electric vehicles are much more costlier. Okay. So and we are not sure about how long it will run. Okay, so we don't have sufficient charging facility or that thing. Okay, but at the same time you need to shift from your the petrol or diesel vehicle to slowly into electric. Okay, so there comes the combination of both. Okay, so that is the context in which we'll be discussing the hybrid vehicle. Okay, if you can combine these two vehicles, because IC engine is very rugged, you can use it roughly, it can overload. So a lot of advantages for IC engine, and we have seen around last 100 years. Okay, is a age of IC engine. Okay, so will be using it in almost all our vehicle. Okay, but the electric, if you want to shift it, it will take more time. Okay, so what we'll do is we are try to combine these two. Okay, some part of the driving will be giving to the IC engine, and some part will be giving to the electric motor. Okay, so that at least your overall efficiency will be improved. Okay, so I mean some part of the driving will be shifted to electric motor. Okay, electric motor means it is having at least 3 times the efficiency than the IC engine. Okay, so that makes the overall system efficiency improve. Okay, so your overall efficiency will be improved. Okay, as well as the emission will be reduced. Okay, so when you are putting some electric motor, your emission at least during that period will be reduced. Okay, as well as the noise will be reducing. Okay, so you have plenty of advantage if you are going for a hybrid vehicle. Okay, so especially in Indian condition. Okay, so you cannot shift all your IC engine based vehicle into electric vehicle in a quick time. Say some 5 or 10 years, you cannot do it quickly because it needs a lot of investment. Okay, and also you need a lot of materials, lot of costs involved in it. Okay, so what we'll do is at least some of our vehicle will be shifting into a hybrid vehicle. Okay, so that is comparatively easier. So in addition to IC engine vehicle, so we'll try to add some amount of electric motor and some electric battery. Okay, so that at least some part of the driving will be taken care by the electric motor. Okay, so if you are going for a pure electric vehicle, new electric vehicle, so it will be comparatively costly. Okay, but if you want to just add some small motor and some small battery pack, so it will not that much costly. Suppose a new electric car may be costing around 10 lakh. Okay, and if you can modify your existing car with some hybrid, okay, so with 1 lakh rupees, okay, and you can reduce the fuel cost, you will be reducing your emission, so that time it will be beneficial. Okay, so that is the model in Indian roads we are looking for. Okay, at least some of your existing IC engine vehicle will be slowly converted into the hybrid vehicle first. Okay, and then later if you want, we can convert into electric vehicles. Okay, so at least some part of, say, some 20% of the vehicles presently running in the Indian roads, if we can convert into hybrid vehicle, okay, so it can reduce the fuel consumption and it can reduce the emission on the road. Okay, and it is cost effective also. Okay, so comparatively you need to invest less amount for the converting into a hybrid vehicle. Okay, so that is the context in which we are talking the hybrid vehicle. Okay, so and if you are looking at the history also, okay, you can see that, okay, there have been the attempts for the hybrid vehicle started much early. Okay, you can see this approximate the timeline of our vehicle. Okay, so we have some steam engines started from steam engine because that is the first engine which we have started. Okay, then the internal combustion engine, the first crude model came in 1806. Okay, then the successful gas driven engine in 1860. Okay, so this is the time actually the electric vehicle started. Yesterday I told 1835 the first model of the toy car run with the electric motor. Okay, so up to 1912 or 1920, that was the golden age of electric vehicle. Okay, so we have seen in US roads around 28% of the vehicle were the electric vehicle during that period. Okay, so that is the peak period of production of EVs. Okay, but from in 1924, okay, suddenly the interest for electric vehicles reduced because of the cheaper IC engine. Okay, and it is more efficient. You need not worry about recharging. Okay, you can easily fill fuel. Okay, so next around the I will say around next 100 years, it was the age of the IC engine. Okay, so we have been using extensively. So presently we have around only the 0.2% of the overall vehicles in the across the globe is the electric vehicle. Okay, So, but then we have the issues started coming. So there was the oil production in the issues in 1970s. Okay, so the U.S. oil crisis. Okay, so that time they started thinking about something beyond oil, which can run without the oil. Okay, so that is why they seriously started talking again on electric vehicle. Okay, then some electric vehicle technology. So by the way, we have got a lot of advancement in the electronics, and also in the power electronics side. Okay, also in the battery, the advancement. Okay, so then by 1990 we have the new generation of electric vehicles. Okay, so the commercially available ones are coming in the market. Okay, so then along with the electric vehicle we have also started the developing the hybrid vehicle. Okay, so now if you are seeing the advertisements of the electric vehicles in the any vehicle, any four-wheeler and all in the market. Okay, most of them having at least some percentage of hybrid in it. Okay, so even though very small percentage, okay, some electric motor they are incorporating in these vehicles, so that you will be getting slightly higher mileage. Okay, so that is how we are improving the efficiency. Okay, with the same amount of fuel, you can run slightly more distance. Okay, so that trend has come actually, I mean, after 2000. Okay, so now you can see that if you are just looking into the advertisements and all, you can see that okay, most of our four-wheelers, two-wheelers, all are having some amount of hybrid in it. Okay, or some electric motor they kept. Okay, so it may not be a very big percentage, but some percentage of hybridization is done for the vehicles. Okay, so we are slowly moving into a higher degree of the hybrid vehicles. Okay. So the actually the attempts have started much early. Okay, so the 1900 itself, actually the Porsche, they have used the hybrid vehicle. So they use their IC engine, so they generate electricity and they used to drive the vehicle. Okay, so that was the first series hybrid model. Okay, so that was done by the Porsche in 1900 itself. Okay, then the 1915 they actually Boots Motor Vehicle manufacturers. Okay, they have come up with the dual power hybrid vehicle. Okay, and but the first the mass production started in 1918 itself. So you see it is more than 100 years back. So there's some 600 models were built by that particular company, or 600 the hybrid vehicles were developed by that company during that time. That was parallel hybrid. Okay, but then there was a big gap because that was the period when we were more concentrated on the fossil fuel vehicles, because they are having the much more efficiency and they can, I mean, they are more flexible, easily controllable. Okay, so but it took a lot of time for the hybrid to come back. Okay, actually in 1960 the Victor Work, so he was known as the godfather of hybrid. Okay, he started converted the four-wheeler into a hybrid. Okay, so that is the modern hybrid vehicle. Okay, then the 1972 we have started implementing the regenerative braking system. Okay, so I'll talk more on the regenerative braking system. So you know, when your vehicle is moving, okay, so it is moving with a lot of energy. Okay, so it is moving with a lot of kinetic energy. Okay, if you want to suddenly break it, okay, you need to dissipate all that energy, or you need to expend all that energy to break the vehicle. Okay, so usually what we'll do is, okay, you are using some kind of brakes. Okay, or the vehicle will be, the entire energy will be spent against the friction. Okay, so that time you are using, I mean, you are wasting the entire energy in friction. Okay, so in the regenerative braking mode, what we are doing is, okay, so we'll be trying to recover the energy while braking. Okay, so when we are trying to brake, so the vehicle, I mean, the total vehicle will be having a lot of weight, a lot of we have seen that why we are going for hybrid. Okay. So hybrid means, okay, in addition to your the IC engine, you will have some the kind of electric battery, okay, and you have some kind of electric motors. Okay. So in the actually this is a comparison chart of different vehicles given in the bottom. Okay, and here we have compared some parameters. Okay, I'll just quickly tell some important points. Okay, so the conventional vehicle actually having slightly the a higher cost, okay, but they are having better range, okay, so compared to the other one, okay, the electric vehicles, okay, so the conventional vehicle having better range, okay, and the fuel cost also slightly higher for the conventional, okay, but the hybrid when it is coming, okay, so the fuel cost you can reduce, okay. Similarly the greenhouse gas emission, okay, so instead of the completely running with IC engine, some part if the electric motor is taking care, okay, so your overall emission will be reduced. Okay, so then the air pollution, okay, air pollution emissions, okay, so normally when electric motor is running in the vehicle, okay, so from the vehicle the pollution will be reduced. Okay, so and then the so you will have improved efficiency and you will be having the improve or less pollution. Okay. So that are the two the things which is the supporting the hybrid vehicle. Okay. So you need not the invest lot of money to get a complete electric vehicle. Instead of that, you can go for some hybridization. Okay. So that requires comparatively lesser amount of investment. Okay. But you will be getting slightly better efficiency. Okay. And you will be getting the less pollution. Okay. So that is why the government's also supporting the hybrid route, okay, because in one step you cannot go for the electric, so you go slowly through the hybridization route. Okay. So the with the hybrid vehicle, so with the minimum modification, you can convert into the existing IC engine vehicle with the minimum modification. You can go for the hybrid vehicle. Okay, so that's why we all are looking for the hybrid vehicle. That's why we have more hybrid vehicles than the pure electric vehicle. Okay. So this is actually the overall efficiency chart. Okay, so the basic question in the for us is, okay, so whether the electric vehicles are really beneficial. Okay, whether the electric vehicles are really beneficial, okay, especially in places like in India. So in India, the problem is, okay, so still around 60% of our electricity is coming from your fossil fuel. Okay, still if you are seeing the Ministry of Power website, okay, you can see the what is the percentage of the conventional generation, what is the percentage of renewable generation. Okay, if you are looking at around and the 60% of the electricity is still coming from the either coal thermal power plant or diesel power plant or the naphtha based power plants. Okay, so still around 60% of your electricity is coming from the fossil fuel. Okay. So, and you are charging your car from electric car from this electricity. Okay. So the car you are charging from this electricity, which is generated from uh, which is after burning the fossil fuel, you are generated electricity, and you are getting the electricity from the grid. Okay. So after burning the fossil fuel, okay, now then you are running the electric vehicle, whether it is really beneficial. Okay. But this is a situation in India. Okay. So some of the European countries, they are having more renewable in their the generation. Okay. So something countries like the Denmark, the Norway, the France, and they all are having around 60 to 80% renewable energy in their electric generation. Okay. So they have more the wind energy, they have more the solar. Okay. So in such countries, okay, you can definitely go for the electric vehicles because you are getting, without burning the fossil fuel. Okay. In India, if you are burning the fossil fuel, then you are generating electricity, then you are going for car. Okay. So charging it. Okay. Whether it is really beneficial. Okay. So that is what actually we are trying to look here. Okay. So this is actually known as the well to wheel. Okay. So normally we are getting your fossil fuel from some oil wells. Okay, so we are extracting from oil in the well. Okay, or we'll be having some coal plants. Okay, so then you'll be generating electricity by using some thermal power plants. Okay, so thermal power plant means you'll be burning the fossil fuel. Okay, then generating electricity. Okay, that generation will be having around 33% efficiency because it's a thermal cycle. Okay, the thermal cycle efficiency is very poor. Okay, so generally we'll be having around 33% efficiency. Okay. Then you will be transmitting it. Okay, so transmitting it over large distance. Okay, so I'm sitting in Bangalore. So here, Bangalore city also getting the electricity from either the Bellary side or the Raichur, or even from Orissa. Okay, otherwise we'll be getting from the Western Ghat region, the Shimoga, the hydroelectric power plant. Okay, but it is transmitting over large distance. Okay, even though the electric transmission is happening at a very high efficiency. Okay, so the long distance transmission will be having around 90-95% efficiency. Okay, so that is the transmission efficiency. Okay, then it is coming into your charging points. Okay, then from where you are charging your car. Okay. So 33 into 94, you will be getting around 31% efficiency. Okay. When you are getting the electricity at your plug point. Okay. So actual in the oil content. Okay. So only the 31% of energy is reaching as electricity at your home. Okay, then you're charging into your vehicle. Okay, so the electric vehicle. Okay, so you have some motor. So the motor will be having around 80-85% efficiency. Okay, then you have all the mechanical system, the transmission system, gear system, clutch, and the suspension system, all that things. So if you are putting together, the overall car efficiency will be around 75-76%. Okay, so if you are going through the entire route, you can see that. Okay, so 31% we are getting as electricity. Okay, from that the car will be having around 76% efficiency. Okay, so the overall efficiency of this vehicle, this system will be around 23%. 23% means, okay, in the whatever the energy content in the oil. Okay, so the 23% you can convert into useful work. Okay, so that is the main cycle. So this is the first stage. We'll be uh, talking as well to tank stage. Okay, then actually from tank to wheel stage, 23% efficiency. The overall efficiency you'll be getting some 23%. Okay, but if you are going through the normal IC engine vehicle. Okay, so you are extracting the oil. Okay, then you have a long process of refineries. Okay, so you are segregating the different components of the petroleum. Okay, so you have petrol, diesel, you have the higher fraction component gases and all. You are refining it. Okay, then you are transmitting it over long distance in different vehicles or trains. Okay, then so the overall efficiency of these stages will be around 80%. Okay, so that is the well to tank. So it is reaching into your the fuel tank. So the efficiency is around 80%. Okay, but when you coming to your vehicle. Okay, so your IC engine efficiency is very poor. Okay, the thermal efficiency of IC engine is around 30%. Okay, then you have the transmission system, the drive system, all that thing. So the overall efficiency of your IC engine vehicle is only 16%. Okay, so if you are if you are multiplying this 80% into 16%, your overall efficiency will be only 13%. Okay. So whereas here, if you are using the electric car, you will be getting higher percentage. Okay. So if I mean, even though if you take some small percentage difference in both cases, okay. So definitely there is an improvement in efficiency. Okay. So as I mentioned, so even 1 or 2% efficiency is a significant value in the case of the transportation sector, because the volume of this sector is huge. Okay. The liters of fuel we are burning every day, it is huge. Okay. So even though we are getting the electricity from your conventional plants, okay, so I mean, running a electric car is a beneficial thing. Okay, so you can reduce the emission, you can improve the overall efficiency. Okay, so that is why even in India we'll be promoting the electric car, okay, because even though your electricity is mostly coming from the fossil fuel. Okay, so I mean, this is the supporting data for the electric vehicles. Okay, but if you have some renewable energy instead of the your fossil fuel, okay, so that will give much more efficiency. Okay, and the emission will be very less. Okay, and you are not the exploiting the natural resources. Okay, because the renewable source is a recurring source, it will not be get exhausted even if you are using it. Okay, so that is why the renewable is the best way. Okay, so actually in this the chart I just compared the different types of sources. Okay, so if we are using the diesel, okay, you will be having some extraction stage, refined stage, then transportation form. Okay, then you have IC engine. Okay, if you are comparing the emission, okay, the well to wheel, okay, so well means from oil well to your the vehicle wheel. Okay, so the overall emission will be, okay, so around the 1222 the carbon dioxide equivalent. So that much is the emission coming the for a per the liter or per kilogram. Okay, so this is a big value. Okay, so the carbon dioxide emission. Okay. Actually, the carbon dioxide emission means it's a carbon dioxide equivalent. So normally we have many the components in the emission. So you have XOS, NOx, the hydrocarbons, the volatile organic components and all. Okay. But usually we'll be telling in terms of only carbon dioxide, because we'll be converting all other the pollutant into carbon dioxide equivalent. Okay, so that's what is the carbon dioxide equivalent value. Okay. Then if you are comparing hydrogen, okay, so you know the fuel cell. Okay, in the fuel cell what we do is, okay, so we'll be using the hydrogen and oxygen. Okay, so you will burn it. Okay, then you will be using it for the powering your vehicle. Okay, that is what is happening in fuel cell. Okay, but how you get the hydrogen and oxygen? So it is they are, I mean, the naturally available in air. Okay, but you cannot use it as such. Okay, so you need to electrolyze the water, okay, and split into hydrogen and oxygen. You need to store it. Okay, so storing as hydrogen is a difficult task, because it is a highly explosive gas. Okay, so you need to have more steps in the preserving them. Okay, then you will be storing it and you'll be giving to the vehicle. Okay, if you follow this route, okay, so the emission will be reduced. Okay, it will be around 320 units of carbon dioxide equivalent. Okay, so I mean, actually it has reduced into 1/4, okay, from our conventional route if you are using a hydrogen cell. Okay, but if you are going for some renewable energy, okay, so small hydropower plants, wind or solar. Okay, so you can get the energy input without any pollution. Okay, without any the utilization of the resources. Okay, then you can have the transmission, then charging. Okay, then you will be using some batteries. Okay, so if you are going through this route, the emission will be reduced into around 1/10. Okay, you can see that. Okay, so it is reduced to 10-15%. Okay, so that is why the best method to use the renewable energy for the electric vehicle propulsion, because they are giving better efficiency. Okay, we have seen the improvement in efficiency. Okay, also in terms of emission, it is better. Okay, so that's why we'll be combining these two into the a hybrid vehicle. Okay, so in the hybrid vehicle, actually here I've shown a simple one. Okay, you have the a battery, okay, and a battery and a electric motor. Okay, so already you have some IC engine here. Okay, you have a fuel tank and IC engine here. In addition to that, we will be adding some more systems. Okay, so that is the some charger, some battery packs. Okay, then the some control mechanism, and then some electric motors. Okay, so this is the hybrid electric vehicle. Okay, so the hybrid electric vehicle, we have different types of hybrid vehicles are there. Okay, so the gasoline IC engine, the IC engine. Okay, and battery. Okay, so here you have the IC engine and battery. Okay, some diesel IC engine and battery. Okay, battery and fuel cell. Okay, so sometimes fuel cell means that the hydrogen based cells. Okay, fuel cell. Okay, and battery and capacitor. Okay, sometimes we are using some super capacitor instead of battery. Okay, so you would heard about the super capacitor. Okay, so they can charge and discharge very fast. Okay, so they can charge huge quantity of power. Okay, but the issue is they'll discharge also very fast. Okay, so that's why it is not so popular in our vehicles and all. Okay, but if some of the city vehicles and all, you can go with the super capacitors. Okay, so every bus stop or every station you can charge. Okay, and you can travel a short distance. Okay, again you charge. Okay, so that model will be available for the super capacitors. Okay, then battery and flywheel. Okay, so the flywheel is the energy storage mechanism. Okay, and battery hybrid. Okay, so there are different types of hybrid electric vehicles. Okay, so and if you are looking at, okay, if you are using some in the fossil fuel or some source, energy source into a vehicle, okay, so how it is spending. Okay, suppose you are filling the oil into the fuel into the vehicle. Okay, so and this energy, where and all this energy is going. Okay, so you are saying that you are just driving it. Even when it is driving, okay, you have different the forces to be overcome. So normally you need to some work to move forward. Okay, while moving, you'll be having some aerodynamic resistance. Okay, some rolling resistance on the road surface. Okay, and then some braking. Okay, and some losses happening in your transmission system, the drive line losses. Okay, so you have the transmission, you have the clutch system, you have the suspension system. Okay, there will be some losses. Okay, and sometimes you'll be keeping the vehicle in the idle condition. Okay, suppose you are suppose you are driving in a city, so usually we'll be having some signals, some idling situations. Okay, and some other additional accessories. So within the vehicle you may be using some music system, some entertainment system and all. Okay, all that power is basically coming from your the fossil fuel. Okay, so these are the approximate percentage of all this the energy. Okay, so generally the standby idle losses will be around the 3% to 5%, depending on the condition in which you are driving. Okay, suppose in a city condition, usually we'll be having the lot of signals. Okay, so you need to brake the vehicle and you need to wait for the traffic signal to get. Okay, so there will be some percentage will be going like that. Okay, and this driveline losses you cannot do anything, because you have a transmission, you have a gear mechanism, so you cannot avoid this one. Okay, aerodynamic resistance means it's by the shape of your vehicle, so you'll be having some aerodynamic resistance. Okay, so especially if you are running in the highway conditions, you will be having more air resistance. Okay, And if your road is smoother, the rolling resistance will be less. Okay, but normally you will not be getting the continuous smooth roads. Okay, so definitely there will be some rolling resistance. Okay, and there will be some braking. So especially when in city conditions, you will be getting more braking. So these losses will be. So these are the typical, I mean, the way in which we are spending the energy in a vehicle. Okay, so why we are looking at is, okay, so any way we can reduce the expenditure of energy. Okay, any place we can improve the efficiency. Okay, so that is why we are looking into this area. Okay, so here actually we are trying to capture in some areas. Okay, so one is this standby and idle condition. Okay, that means, okay, suppose you are braking in a city traffic. Okay, so you have the signal there. Okay, your vehicle is stopping there. Okay, so most of the time your vehicle will be and the vehicle engine will be running, so but you are not utilizing that power. Okay, so that is why this the standby loss or idle loss is coming. Okay, so if you can use that power, okay, you need not run the vehicle during that period. So you are just stopped it in the traffic signal. Okay, so whether you can use that the energy which is happening or which is driving during that period. Okay, whether you can store that energy back into that battery. Okay, that will be good. Okay, so this is the one area we can easily tap the energy. Okay, so when the vehicle is not moving forward, okay, and the engine is running, so that time you will be trying to retrieve the energy. Okay, so this is the one area. Okay, another area is the braking. Okay, so we'll be going for the regenerative braking. Okay, earlier I mentioned what is regenerative braking. So while braking, we'll try to retrieve that energy. So we'll try to store it in the battery. Okay, so these are the areas mainly we are first started looking. Okay, so we'll be looking for the regenerative braking. Okay, and more efficient operation of the IC engine. Okay, so we'll try to improve the IC engine efficiency. Okay, so now the problem is you have a single IC engine. Okay, so it is running it in different condition. Okay, suppose you are climbing a hill. Okay, it is using more power. Okay, if it is running on a smooth road, it is running at a higher speed at a lower torque. Okay, and then sometimes you are going into the pits on the roads and you are going into the some rough driving condition. Okay, even though the engine is same, you are using different power or different driving condition for this IC engine. Okay, so under different driving conditions, the IC engine working at different efficiency points. Okay, so you remember the efficiency curve. Okay, so the efficiency curve, it is increasing and it is saturating. Okay, so I mean when you are driving the vehicle under different driving condition, okay, your efficiency will be different at different points. Okay, sometimes you are driving uphill. Okay, so you are going in the lower gear. Okay, and sometimes you will be running on a smooth highway, you will be going at a higher gear. Okay, so all these points the efficiency will be different. Okay, so if you can run the IC engine at the best efficiency always, okay, or if you can run the engine at a better efficiency, okay, your overall efficiency will be improved. Okay, so that is the one area the hybrid electric vehicle is looking for. Okay, so you are trying to improve the efficiency of your IC engine. Okay, and another thing is that, okay, so what we have tried is, okay, so in addition to your IC engine, okay, we are trying to put some electric motor. Okay, and what we are trying is, okay, we are trying to give some amount of work into the electric motor. Okay, instead of completely doing the work by IC engine, some part of work we are shifting to electric motor. Okay, so in that case, actually, while designing, you can go for a slightly smaller powered IC engine. because the some power is taken care of by the electric motor. Okay, so your overall the size of the overall the capacity of the IC engine you can reduce. Okay, so the some amount of that work is transferred to the electric motor, so you can have a smaller IC engine, comparatively smaller IC engine. Okay, but there are some issues for the hybrid electric vehicle when you are putting some additional electric motor, battery, all that things. Okay, so your weight will be increased. Okay, so you need to put some additional battery pack, you need to put some additional the motor and some power electronic system and all. Okay, so you need to put some additional investment in your existing car. Okay, as well as it will increase its weight. Okay, when the vehicle weight is increased, okay, so you need to drive that additional weight also. Okay, so that is a disadvantage for the hybrid vehicle. Okay, so the potential for higher weight. Okay, and also you'll be having some additional electric losses because you are using a electric motor. Okay, and you have a battery pack, so you'll be having some slightly higher electric losses. Okay, so this is a typical the vehicle with the battery pack and electric motor, which is shown here. Okay, so if you are seeing from a bottom, it will be like this. So I think this would have already covered. So we have basically the different types of this hybrid vehicle. Okay, so we have the series hybrid. Okay, series hybrid means, okay, you are just presently almost all our vehicles are series hybrid. Okay, you'll just fill only fuel. Okay, only the petrol or diesel will be filling it. Okay, then you will be having an IC engine. Okay, when the IC engine is running, so there will be an alternator coupled to it. Okay, so it will generate electricity. That by using that electricity will run the electric motor. Okay, if some additional energy is there, that will store it in the battery. Okay, so you can see here the engine, the vehicle transmission is driven only by the electric motor. Okay, it is only driven by the electric motor because it is not connected to the IC engine. Okay, the transmission is connected to only the electric motor. Okay, all these are in series. Okay, so fuel tank, IC engine, generator, the power converter, the electric motor, all are in series. Okay, so that is why it is known as series hybrid. Okay, so then you may be thinking that why it is required, because you are already running the IC engine. Okay, then after that you have a generation stage. Okay, after that you have some battery power converter stage, then electric motor. Okay, so all these stage will be reducing the efficiency. Okay, so but the advantage is, okay, you can run the IC engine always at the best efficiency point. Okay, so you remember the efficiency curve. You can run the IC engine always at the best efficiency point. Okay, so that you need not change its speed or torque of this IC engine. Okay, you'll be running always at best efficiency. Okay, so that you'll be getting better efficiency than your conventional running. Okay, better efficiency than your conventional running. So if the motor requires less power, that additional power you'll be storing it in the battery. Okay, or if the motor needs more power, you can take power from the battery. Okay, so some of the electric vehicles are now in the series hybrid. Okay, so this is how a series hybrid works. Okay, but whereas the parallel hybrid, you can see that, okay, so both the IC engine as well as the electric motor is connected to your transmission system. Okay, so actually this vehicle can run with the IC engine alone, okay, electric motor alone, okay, or with both together. Okay, both IC engine and electric motor you can run together using a mechanical coupler. Okay, you can run together. Okay, so this is what is a parallel hybrid. Okay, so both the IC engine and electric motor is using to drive the transmission. Okay, and we have some combination of the series parallel hybrid. You can see that. Okay, So it can have the generator here, okay, and it can run it through this route. Okay, so this is a series parallel, can run as series alone, it can run as parallel alone, okay, or it can run as series parallel. Okay. And then you have a complex hybrid. Actually, this is also having both the ways the power can be driven in the motor generator mode or generator motor mode. Okay, so that is a complex hybrid. Okay, so these are the different options of hybrid available. Okay, so this is actually a series hybrid. Okay, so actually you can see that this is your vehicle, the wheels. Okay, and what we are doing is we are just putting the fuel. Okay, and this engine will be running. Okay, and you can see that engine characteristics will be always running at the best operating point. Okay, that means the engine is always running at the best efficiency point. Okay, so you will have better output. Okay, then some generator is coupled to it. Okay, you are coupling some generator or alternator it. Okay, then the generator will generate electricity. Okay, so that will be rectifying it. Okay, and storing it in the battery using some DC converter. You can send this way. Okay, so you can store it in the battery. Okay, then this DC converter is capable of the bidirectional power flow. Okay, it can take the power in and it can take the power give to the motor. Okay, then that motor will be running. Okay, and that motor will be driving your vehicle. Okay, so you can see that fuel tank, engine, the battery, then the motor. So this is a series part. Okay, so I mean actually in some vehicles, okay, its battery pack can be externally charged also. Okay, so in the series hybrid, okay, the advantage is you can run the engine always at best point, okay, best efficiency point. Okay, you need not worry about what condition you are driving. Okay, this is always running at the best efficiency point, so that your overall efficiency will be improved. Okay, so this is what is a series hybrid. Okay, so series hybrid actually there are the different operating mode. What are the operating mode? We are taking the power only from the fuel tank. Okay, so the power is always flowing from your fuel tank. Okay, and then the engine is running. Then you have generator. Okay, then the electric converter, so you can store it in the battery. Okay, from battery you can drive the electric motor. Okay, so it is always the electric motor is driving your vehicle. Okay, so that is a series hybrid. Okay, so it is having some benefit. Okay, in some cases we'll be using the series hybrid. Okay, so this actually we have tried some setup it in our laboratory. Okay, some series hybrid we have tested. Actually, this is an IC engine. Okay, so actually a two-wheeler engine we had. Okay, so a Yamaha engine. Okay, so we have we have an alternator with it. Okay, and by using that alternator we have the generated the power and stored it in the battery. Okay, and that from that battery we were running this electric motor by using this electric controller. Okay, and we have tested it. Okay, so the series mode actually it was trying the I mean it was working well. Okay, actually this IC engine the is a Yamaha engine, two-wheeler engine. Okay, so what we have done is, okay, we have an open ECU for that vehicle. Okay, so we can always tune it into the efficiency point. Okay, by using the ECU tuning, we were trying to get the best efficiency for that particular engine. Okay, and then we were running this is a BLDC motor. Okay, so actually we were trying to keep it for a small vehicle. Okay, so this is a brushless DC motor. Okay, so this is a series hybrid. Okay, so by using the IC engine, you are storing it in the battery. Okay, from that battery, you are driving your motor. Okay, so and actually in our lab we are testing with our students. So the performance was better. Also, we are doing the ECU tuning. Okay. Then the parallel hybrid, actually the two paths are there. Okay, you have the vehicle with the transmission. Okay, so you have fuel tank and engine. Okay, and you have the battery and the electric motor. Okay, and you have now two systems. Okay, your engine shaft can drive your vehicle, okay, alone, okay, and as well as the electric motor shaft can drive your vehicle. Okay, so if it is if you want to drive them separately, it's fine. Okay, you can drive them separately. Okay, but it is capable of driving them together also. Okay, suppose you need more power. Okay, so you need to use both the IC engine as well as the electric motor. Okay, so you need to couple these two outputs together. Okay, so this coupling requires some, I mean, some serious techniques, because sometimes this IC engine may be running it in a different speed. Okay, the motor may be running it in a different speed. Okay, but how you will be coupling these together? Okay, so usually we'll be using something known as the torque coupling. Okay, something known as the torque coupling. So that means, okay, the two input torque we are adding together. Okay, two power we are adding together. Okay, and that by using that power we'll be giving to vehicle shaft or vehicle transmission. Okay, so that is required in a hybrid vehicle, because hybrid vehicle you can see that the two systems are using to drive the vehicle. Okay, so here you need to use some coupler. Okay, so we are using some torque coupler, or we have some the pulley chain assembly arrangement. Okay, so in some cases, okay, and some cases we are using some planetary gears. Okay, some gears like this. Okay, some planetary gears we are using to couple this torque together. Okay, so this is actually some speed coupling by using some the planetary gears. Okay, so actually you are giving two inputs. Okay, and one output we are taking from the middle. Okay, so that both will be added together, and this final shaft will be moving in only one speed. Okay, so hope you understood the issue of coupling. Okay, because you have the engine, okay, it is driving it in one speed. Okay, and you have the electric motor, it may be slightly different speed. Okay, or different torque. Okay, will be adding together to drive your vehicle. Okay, so you need to add together to drive the shaft. Okay, so you can use either the pulley chain methods. Okay, or you can go for this types of gears, planetary gears. Okay, or you can go for some speed coupling. Okay, so we have tried the parallel hybrid. Okay, so this is the type of the planetary gear mechanism which we are used in our hybrid electric vehicle model. Okay, actually this is first we are the done some simulations. Actually this models we have made a prototype. Okay, so in the lab. Okay, you can see that one side you have a motor and another side another motor. Actually instead of IC engine within the lab setup we are use another motor. Okay, and then we have the couple them using a set of planetary gears. Okay, so that you can add, I mean you can run the transmission system with only the electric motor or only with the IC engine. Okay, or by using this coupling you can run with both. Okay, so this is the type of mechanism we are used. Okay, you can see that. Okay, so one side we have the electric motor, other side we are connected the IC engine. Okay, in between this particular coupling is coming. Okay, so this particular coupling is coming in between. Okay, so you can see that, I mean this coupling can disengage. That means you can run only with IC engine. Okay, or you can run only with electric motor. Okay, or by using this coupler you can run with both. Okay, so this type of the mechanism actually we are used in this particular small vehicle. Okay, so this the all-terrain vehicle. Okay, so actually this we are developed in the campus. Okay, so they are taken in for a competition. So the KPIT Sparkle. So it was a national level competition. So they reached into the final stages. Okay, so the final the sixth position something they got it. Okay, so actually this vehicle having an IC engine in the front. Okay, and the electric motor at the back side. Okay, and this coupling is done by using this particular torque coupling, so that we are getting the power adding together, so that we are done. So actually our students have done it in our lab, this particular vehicle. Okay, I think photo is having some issue. Okay, so this was a electric motor we are used. Okay, and we have a electric set of battery here. Okay, so for this vehicle we are used only the lead acid battery. Okay, so because of the cost constraints we are used only the lead acid battery. Okay, then we were controlling them together and we were coupling it them by using that planetary gears. Okay, and the another important thing is, okay, for the hybrid vehicle is the energy management system. Okay, so now you have the two options for driving the vehicle. Okay, so you can drive with your IC engine alone. Okay, or you can drive with the electric motor alone. Okay, and you have the provision to use both together. Okay, so this is a parallel hybrid. So this is what is known as a parallel hybrid. Okay, now the question is, okay, where I'll use the electric motor, where I'll use the IC engine. Okay, suppose in the starting period, which one I to use. Okay, so when you are climbing a hill or when you need more power, okay, which one I'll use. Okay, or when you are running in a smooth road, okay, which one I'll use. Okay, so the basic answer to this is, okay, which is giving the better performance, that we'll use. Okay, so generally what we are doing is, okay, so the starting period we are using the electric motor. Okay, so to support the starting. Okay, then the IC engine is the lower speed conditions. The IC engine is taking care of the driving. Okay, and in the smooth road condition, or if the speed is attaining a certain limit, okay, then we'll be running only with the electric motor. Okay, so that kind of the mechanism which we have tried. Okay, so the actually in the we have tried some different algorithms. Okay, so which model will be using, okay, for driving it. Okay, so actually this is a small model. Okay, so within the lab setup we have tried. So actually this Raspberry Pi, the microcontroller. Okay, so here we have put the programs, okay, to control which set of the the prime mover to be used, whether the IC engine or the electric motor. Okay, so how they use this? Okay, so we have some road conditions we have given. Okay, if the road slope is this much, then you try to go for this mode. Okay, or if it is road condition is, if there is no road slope, if it is smooth, then you go for the electric motor. Okay, or if the speed is the greater than this condition, then go for electric. Okay, if speed is less than this condition, then go for the IC engine. Okay, so like that, different algorithms we have tried. Okay, so to check which is the best efficiency. Okay, so actually this is a prototype model. Actually here there is no IC engine used. Instead of that, okay, we have used some electric motors in the front side and electric motors in the back side. Okay, and we were trying the different algorithms on this board. Okay, so that your energy management system, which is giving better overall efficiency. Okay, so that way you can drive your system. Okay, so generally in the hybrid electric vehicles, such a energy management system is important. Okay, so that is the brain of the system. So that brain is telling which mode you need to use, whether you need to use the electric motor or whether you need to use the IC engine. Okay, which is giving the better efficiency, that we'll be using. Okay, so actually in this system, actually we are you also use some road map. Okay, so we have taken the road conditions from the some GPS, the information we have taken. Okay, so that you will be getting the road condition, whether you are having any slope is there, or whether it is a smooth road, any traffic is there. So not traffic, the obstacles. Okay, so we have taken only the geographic information. Okay, so based on that, they tried the different algorithms, okay, and they have mapped into the which is the best the operating condition. Okay, so such a the energy management system is required for your the hybrid vehicle. Okay, then only you can tell which one will be using during what period. Okay, so even though you have these two options are available, okay, which one will be using? Okay, so whether you need to go for IC engine, whether you need to go for electric motor. Okay, so once you have this program on board, okay, it will automatically the getting the input, okay, and it will automatically take decision on which the direction you need to go, okay, or which the method you will be using. Okay, so that is what is the importance of energy management system. Okay, so you will be having a energy management unit. Okay, so which is taking care of the entire system. Okay, and which will tell whether your battery pack to be excited, or whether you will be using the energy fueling unit. Okay, so which you need to the activate at a time. Okay, so the energy management system will be getting information from all these sensors. Okay, so what is your drive condition? What is your the acceleration period? What is your braking? Okay, how much is the steering? So what is the temperature? So in a vehicle system, you have plenty of the subsystems and you have plenty of sensors. Okay, all that sensor information will be using to the whichever the relevant information will use to do the energy management calculation. Okay, so generally the energy management unit is a slightly complex unit because you need to process a lot of inputs. Okay, and under all that you mean the inputs will try to take the best decision. Okay, which method will be trying to take it. Okay. So that is the energy management system. Okay, you can see that. Okay, you have a split parallel device here. Okay, so you are getting the information from the engine controller, motor controller, so all the inputs you are getting. Okay, and then you'll be controlling your vehicle. Okay, so from there you'll be sending the signal to your motor controller, generator controller, battery controller, and all. Okay, so actually, this we have simulated and we have tried it in. We tried it in a smaller scale. We didn't try all the options, okay, but only some information based on the road condition, okay, and some information based on the speed condition. Okay, so below the speed, use this one. Okay, above the speed, use this one. Okay, if the slope is this much, then you go for this one. Okay, so like that, some fuzzy rules we are used to control that HEV mode. Okay, actually that the information also we have tried it in this particular vehicle. Okay, so that's the energy management system. Okay, so you have seen some examples of the hybrid. Okay, but in your market, if you are seeing that, you can see that many vehicles are coming with the tag hybrid tag. Okay, so and it is all are not fully hybrid. Okay, so fully hybrid means, okay, so you can able to run the vehicle with only IC engine alone and only electric motor alone. Okay, and they can work together also. That is what is known as the full hybrid. Okay, but in normal cars, what we are doing is, okay, so I have shown a diagram here. So we have the utilization of energy. Okay, so standby energy, the energy you can utilize, or some braking energy you can utilize. Okay, so actually in the first stage of hybrid, the first stage of hybrid is known as the micro hybrid. Okay. Micro hybrid, actually we are what we are doing is we are taking the energy during the idling period. Idling period means something like in the signal your vehicle engine is on, but the vehicle is not moving. That time, that energy will be storing it in your battery. Okay. So that is what is known as the micro hybrid. Okay, Mild hybrid means in addition to this, okay, you'll be using some regenerative braking. Okay, so by using the regenerative braking, you can save some 2-3% of energy. Okay, so that is the regenerative braking. Okay, and the electric motor will be using to support the combustion engine. Some areas will be trying to support that one, not always. Okay, some limited cases will be supporting that one. So that is the mild hybrid. Okay, so it is having the idling. Okay, so then it is be having the regenerative braking, and rarely it supports the IC engine. Okay, but in the full hybrid, okay, in addition to this, you can drive the vehicle only with the electric motor. Okay, so this electric motor means it should be having the same capacity as your IC engine. Okay, so at times it should be able to drive the electric vehicle. Okay, so that is the full hybrid. Okay, the plug-in hybrid means actually you are capable of driving it as full electric vehicle. Okay, so you need not fill the fossil fuel at all. Okay, so you can charge from the battery and you can run it as an electric vehicle itself. Okay, so even though it is a hybrid, you can run it as a plug-in in the electric also. Okay, so these are the different types of hybrid vehicles. Okay, we'll be calling it is the degrees of hybridization. Okay, so we have the micro hybrid, the mild hybrid, okay, the full hybrid, and plug-in hybrid. Okay, so we have different models of cars available here. Okay, so we'll show that. Okay, so what I'll do now is I'll just show some tools which we will be using to simulate the hybrid vehicle. So especially those who are doing the research or those who are doing some experiment with the vehicles. Okay, so the tools are helpful. Okay, actually this advisor is a small package. Okay, so but the advisor is running over the MATLAB. Okay, so you know the MATLAB. Okay, so actually the MATLAB is powerful software. Okay, but this advisor is a small package which you can run over the MATLAB. Okay, so it is a advanced. Advisor, the full form itself is the advanced vehicle simulation software. Okay, so actually it's the advanced vehicle simulator. Okay, so here what we can do is, okay, we can actually test your vehicle under different conditions. Okay, different driving conditions you can test your vehicle. Okay, test means, okay, so you have some certain kind of hybrid vehicle. So here in the library itself there are some standard vehicles, the formats are given. Okay, you can take that one and you can modify it. Okay, if you want to modify it, and you can have your own models and you can edit it and do it. Okay, then you can simulate it for different running conditions. Okay, suppose I want to run it in some city conditions in India. Okay, you can try. So how much will be the efficiency you are getting? Okay, and you can compare some other vehicle, or you can compare with some other model. Okay, and then you can change the different components and check. Okay, so it's a very simple tool. Okay, because this doesn't require much the technical knowledge and all. Okay, so you can easily run it. Okay, but the issue is, okay, you need to have MATLAB for this one. Okay, so those who are having the MATLAB, okay, so you can download the advisor software from the online. Okay, it is free software. Okay, so but to run that you need to have some MATLAB account. Okay, or MATLAB software. Okay, then you can run it over that. Okay, so actually you can estimate the fuel efficiency of the vehicle by using that one. Okay, and then how much the energy used, how much is the battery used. Okay, and then you can analyze the emissions of this vehicle. Okay, you can see that under different running condition how much is your emission. Okay, then you can evaluate your energy management strategy. Okay, so the fuel converter, what kind of energy management you will be better. Okay, and you can try with the different the gear ratios, the transmission. Okay, so which will be giving the better efficiency. Okay, so I mean, actually this is not a design tool. Okay, so you can only evaluate. Okay, so you have some model. Okay, if you are having some vehicle model, then you can test it under different conditions. Okay, you can change the vehicle data. You can change the road conditions. Okay, and some speed race, all that things you can change. Okay, then you can analyze that. Okay, so I think I'll just. Okay. So before going that, I'll just tell the something on the drive cycle. Okay. So those who are used the simulation, they know what is a drive cycle. Okay. So drive cycle means, okay, suppose in the you are driving your vehicle. Okay, suppose you are driving your four-wheeler. Okay, so when in Indian condition, when you are driving, so some part you will be having free roads. Okay, then there will be some the bends or some traffic signal or some villages coming or some humps will be coming. Okay, then and there you will be getting some smooth roads. Okay, then you can go faster. Okay, so actually drive cycle is a particular driving the series of driving points. Okay, so it is actually the speed versus time plot. Okay, so actually there are some standard drive cycles. Okay, so in Indian road condition there is an Indian standard drive cycle. Okay, and the city driving will be different from the what is your rural driving. Okay, so there are some internationally accepted drive cycle. Okay, these drive cycles which we are using to test your vehicle. Okay, to test your vehicle performance, we'll be using this type of test, the drive cycle. Okay, so because this includes the acceleration, deceleration, braking, the slowing down, the okay, everything is covered in this particular drive cycle. So in the advanced vehicle simulator software also we'll use some kind of drive cycles to analyze your performance. Okay, so actually this is a slightly longer period, so it's a 1200 seconds or 1400 seconds is the normal period for one drive cycle. Okay, so that vehicle will be tested for that complete drive cycle. Okay, so that is what we'll be doing. Okay, so uh, I'll quickly show how we'll be using that one.
I request all the participants to kindly ask any questions if you have.
I'll just quickly show that the this also. So whether the MATLAB is visible screen?
Yes, sir.
Okay. So actually, this is a MATLAB. So here there is a small toolbox I installed. Actually, this is Advisor. Okay. So if you are just googling it, Advisor vehicle simulator, there is a small pack, some 30 MB. You need to download. Okay, and you need to the download and just keep it in your MATLAB folder. Okay. So then you can run it. Okay. So if you just run the advisor, so you will be getting a small platform like this. Okay, so here you can select which type of unit you want, metric or US. Okay, so then you can go for start. Okay, so I told this is a platform to test your vehicles. Okay, so the first thing is that here there are a lot of options there. Okay, you can go for the parallel hybrid, series hybrid, all that thing. Okay, so I just taken some the parallel hybrid. So if you are selecting that one, so it will be loading that one. You can see that is a parallel hybrid. You have a electric, the battery pack is there. You have some the electric motor is there. Okay, then some IC engine is there. Okay, so the IC engine is here. Okay, so this is a model which we have selected. Okay, so here if you want to change the type of vehicle, there are plenty of the vehicles available in the in this library. Okay, you can select some vehicle. Okay, if you want a particular one, you can take. Okay, and what type of fuel converter you want. Okay, so IC engine or fuel cell, which one you want, you can take. Okay, also you can have the separate type of fuel converters. Okay, so based on your vehicle you can select it. Okay, and the exhaust artifact, so how is the exhaust the condition, so that you can give. Okay. Energy storage, whether you need the internal energy storage or external or separate type, so that you can select. Okay, and the motor. Okay, so different types of motors are available. Permanent magnet, the motor controller. Okay, so this one is having only one motor. Some, I mean, the car's model, if you are selecting, it will be having two models. Okay, then the transmission, you can select different types of transmission: manual, automatic, or the CVT or PGCVT. So you can select for the different types of transmission. Okay, then the torque coupling, what type of torque coupling you want. Okay, you can select some torque coupling. Okay, then the wheel axis, what type of it. Okay, then different accessories. Okay, so the powertrain control. So all these things you can select and change. Okay, so you can basically test many vehicles with many different connections. I'll show that connection diagram. Okay, then whether you need to go for the front wheel drive or rear wheel drive. Okay, so or the four wheel drive, so which drive it is, so you can select that one. Okay, so this is the type of the vehicle I selected. Okay, now, I mean, what are the values you need to compare. Okay, suppose you need to compare the fuel converter or torque coupling. So what are the variables you need to control, so you can actually the control, I mean, select that one. Okay, so now if you are the actually I selected some vehicle with something. Okay, so now I can actually see the what is the block diagram of this particular connection. Okay, so here actually I have some the hybrid vehicle with the electric and the this one. Okay, so I have selected some component. Okay, so basically this is what is the block diagram. It is generated in MATLAB. Okay, so you have some the drive cycle, so that will give next stage. Okay, and this is a vehicle model. Okay, so you have selected a particular vehicle model. Okay, that model is here. Okay, then you have the wheel and axle assembly. You can select different wheel and axle assembly. Okay, based on that you have actually the model it is selected. Okay, then you have the driveline converters, the final drive, you have the gearbox, and you have the torque coupler. Okay, so you can basically select different from your menu list. Okay, so this all will be changing. This is a motor controller. Okay, this is the electric axle, I mean the accelerator loads. Okay, so this is the power connection and the battery. Okay, and this is the IC fuel converter and the exhaust systems. Okay, so all these systems, you if you want to change, you can change. Okay, so these are mechanical access loads. Okay, and I mean you can see the components also, what are the things there. Okay, so this is the actually the electric assist control unit. Okay, so you can actually modify that also. Okay, and these are the clutch system. Okay, so this is a complete block diagram of that picture we have shown. Okay, so we have the vehicle with all the transmission gear, all these things. Then you have the battery, electrical motors, and then IC engine, all the energy management system. Then you have the exhaust system. So this is the MATLAB model for this particular the system. Okay, now okay, so now I mean this particular system we have taken. Okay, so this particular system we have taken. So now you can actually check which one you want to see. Okay, whether the motor efficiency or the you need to see the fuel converter efficiency. Okay, so or you need to see the transmission efficiency. Okay, so all that things you can plot by using this. Okay, so now I have selected my vehicle. Okay, so that block diagram is showing how my vehicle is selected. Okay, so now if I'm continuing with that. Okay, So here actually I can change the drive cycle. Okay, so drive cycle I told, okay, so it's a particular driving condition. Okay, so there are some standard driving conditions actually, the I mean internationally accepted. So normally when people or companies are designing their the drive cycle, so this is a constant drive cycle. Okay, you can have a different drive cycle, this is a different drive cycle. You can see that this is speed, okay, and the time, okay, speed versus time, okay, and I mean you can the having Indian drive condition. So this is the Indian highway conditions. Okay, so not change. Okay, so you have different driving condition you can select. Okay, then the road grading you can select. Okay, then the any SOC correction or the cycle filter that you can do. Okay, then if you want to run for multiple cycles, okay, that is also possible. Okay, otherwise usually it will be running for only one cycle. Okay, and the test procedure also. Okay, internationally the vehicle testing, so the city highway or city highway hybrid, so whatever condition you need to test, you can actually test with that particular conditions. Okay, then the if you want to do acceleration testing, the you can give the acceleration options, grading options. Okay, so you can change here, so what are the acceleration options and all. Okay, then you can actually run the system. I'll just change the I'll change into the city highway. Okay, so I'll try to run with these conditions. Okay, so here it is very simple, you can just run it. Okay, so if you are running it, okay, so you'll be getting the, it's a bit slow. It's picking up some updates. Okay, okay, so it will be started simulating. So what is your SOC levels? Okay, so what is your the, it's just loading. Okay, so actually this vehicle simulator software is a simple one. Okay, I mean you need not do any programming, you need not the do any complex things. Okay, so but you can easily compare the types of vehicles. So you can have the different types of the driving systems. Okay, so you can have different types of the fuel converters. Okay, all that things you can compare it. Okay, I think something is running parallel. The simulation is running. Okay, so I mean you can also use. I think by the way it is coming up. Close it and see. So I mean you can see the. I mean the graphs. I'll try to see here. Okay, so you can see the systems and you can simulate it. You can and you can compare it. Okay, so this is a one easier tool for the testing the hybrid electric vehicles. So the you can also try. So you just go to the Google and you can the try downloading the advisor software. And if you are having the MATLAB, so you can run it, just keep it in the same folder. Okay, so just keep it in the same folder and just give the advisor, it will automatically run here. Then you can change the parameter and see how it is working. Okay, so that is how this particular software is running. Okay, and I mean if you are having the MATLAB, okay, there are the lot more the examples are available in the MATLAB. Okay, so actually I'll just check any models are. Okay, so there are a few. I have some examples. Okay, so I mean, actually, if you are having the MATLAB, you have the plenty of the examples available. Okay, so you can actually test your I mean the hybrid electric vehicle. So basically, by using the Simulink, you can test. Okay, so the it's easily a lot of files are available. So in case I mean any help required, you can the contact us also. Okay, so I think the vehicle simulation software is a simple one. You can try using it. Okay, so it's you can run it from your the system itself. Okay, so the only thing is that MATLAB is required. So basically, we use MATLAB for the many other purpose also. Okay, so as engineers, so we are trying to use that one. Okay, and we have another software in the campus, so that's another licensed software, so that is known as IPG car maker. Okay, so but it is having only limited licenses. Okay, so that we are using for testing within our lab conditions. Okay, so the thank you for the patient listening. So over to you, sir. So
Yes, sir.
any
We have one
question?
question in chat box, sir. I will read
Okay,
out.
okay, I'll check it.
Okay, okay, sir.
Yeah, actually, the overall weight ratio of EV and IC engine vehicle. Okay, so if it is a pure EV, then the weight will be. I mean, actually, EV will be having slightly higher weight. Okay, because the battery packs are the slightly heavier. Okay, so generally the EVs will be having higher weight than the IC engine. Okay, so because and the problem you are seeing that our earlier the electric vehicles were only two-seaters. The your Reva and all you have seen earlier. Okay, so it is only just two-seater because the lot of weight is consumed by the battery pack itself. Okay, so still it is a truth that the EV will be slightly higher weight. Okay, so I mean that is mainly because the battery pack. So that's why the battery pack we are keeping at the the bottom level. Okay, so that the weight issues also will be trying to reduce. Okay, so presently EV is having higher higher weight. Okay. And so any other questions? So you can unmute and ask also.
Maybe you can unmute and ask yourself, and if you have any questions, you can directly ask to the resource person.
Okay, so what is my suggestion is, okay, so you can all try some projects in the area of the hybrid or electric vehicles. Okay, so because a lot of scope there. Okay, and it's a slightly newer area. Okay, and in your the campus also you can try some hardware project also. Okay, and lot of options are there. It is not only for any particular branch. Okay, actually we are
Hello,
from
sir.
electrical department, but we also do the vehicle related things. Okay, and some kind of programming also involved
Hello,
here.
sir.
Yeah, please.
Sir, so in which way can we get the maximum capacity of the battery?
I mean, can we get actually the capacity of the batteries having limitation. Okay, so the when you are buying the vehicle or when you are going for a particular vehicle, you have a particular battery bank. Okay, so each vehicle having a particular battery bank. Okay, so battery pack, so that will be having a particular capacity. So you have some the 400 volt ampere hour or some 200 ampere hour. Okay, so depending on that battery pack, you will be getting the maximum range. Okay, if it is less range, then you will be getting the less capacity, you will be getting the less range. Okay, so it mainly depends on the how much battery you have. Okay, so the range is depending on that one. I think that is your question.
Thank you, sir.
Yeah. And nowadays, actually, the new vehicles you need to see, the four-wheelers are offering 250 kilometers and all. Okay, even in the some 250 kilometers range and all they are offering now. Okay, so in Indian road condition, 250 kilometers and all with a single charge, it is remarkable. So hopefully we'll be having better range coming in the coming years. Okay, so 250 kilometers and or 350 kilometers and all somebody is offering. Okay, so then it is comparable with your the fuel vehicle. Okay, so it'll be definitely have a lot of market. Okay. So, I mean, actually, my mail ID also I given here, or my number also given here. So, in case you have any issues or any questions, you can contact us. Okay, so we are happy to help you. Okay, if you are having any the the support, if you want, you can ask us.
Sir, I have one
Yeah,
question. While buying the hybrid vehicles,
yeah.
what are the criteria we have to look after?
No,
That
the
means which model
yeah,
better than
the actually two criterions are there basically. So the as from consumer point of view, okay. So how much you need to additionally pay? Okay, so compared with your some other vehicles in the same category. Okay, suppose the you have some option A with some IC engine alone. Okay, option B as this hybrid. Okay, so how much the extra you have to pay? Okay, so I mean this extra payment whether you can get back through your the fuel bill. Okay, suppose instead of the 20 kilometer the per liter, if you are getting some 22 kilometer per liter for the hybrid vehicle, okay, within how many years I will be getting my money back? Okay, so that is the simple consumer calculation. So if I mean the which is favoring you, you'll be going for that model. Okay, so it's very simple. So you need to check for the cost benefit analysis.
sir? Thank you so much. Any participants having any questions in this regarding in this session? Okay, so if no participants having any questions, just we will wind it off. Sir, Anish sir, we are very thankful to you for accepting our invitation. And here you are delivered two sessions on consecutive days. One is on revolution of e-vehicles, and another one is now today hybrid electric vehicles and its performance. We are very happy for listening your talk here. So we are really wonderful to know how the things are happening in electric vehicles, and I have don't know so many things regarding this, and that's why I have chosen this subject. And now I am learning so much of things here. Hope all the participants has gained a lot of knowledge in this hybrid electric vehicles, because in our Indian scenario presently we have so many hybrid electric vehicles. I hope so. Even Swift, and also we have Ertiga. That is also we have hybrid vehicles available in that case. So we are all happy because of the content you are delivered, and really we are enriched our knowledge with your beautiful sessions. So hopefully in the future also we may get a lot of sessions in the next upcoming FTPs if we conducted. So we are very thankful to you, sir. And on behalf of our institution and on behalf of all the participants, we wish a very thanks to you for accepting our invitation and to be here for delivering the lectures, sir. Thank you very much.
Okay, okay. So thank you. Thank you,
And
sir.
also, I'm very thankful to you for suggesting so many resource persons for other sessions also, and giving so much of knowledge regarding electric vehicles. You have given a lot of inputs regarding this FDP also. We are very thankful to you that one also, for sir.
Oh, okay, so thank you all the participants. So we know these 5 days. So the some sessions will be in the tough. So I mean, some sessions you cannot understand completely, but in the I mean, with this FTP, I think you will be getting a lot of input. So you'll be getting a lot of ideas from different people. Okay, so I mean, even though you are not completely understand all the concepts, okay, but the mindset will be definitely changed. So you'll be getting some confidence to take up some new projects or new things in this area. Okay, so definitely that is what we are looking from all of you. Okay, so and thank you for the patient listening. So thank you for the wonderful organization, the Government Polytechnic Harapanalli, okay, and the Mr. Dhruv Kumar, he was contacting me the all these days. So he was giving me all the support. Okay, so thank you all the participants. So thank you for. Okay. So
Thank you, sir.
and hopefully we'll be meeting in person sometime soon. Okay, so we are still in the pandemic period, so hopefully we can visit somewhere there. Okay,
Yes,
thank
sir.
you.
Thank you for your nice inputs. Thank you, sir.
Okay,
Thanks, sir.
thank you.
So, instructions to all the participants. Our next session will be starting at 2:30 p.m. Kindly join by 2:25 p.m. So, thank you. Thank you all. We are ending the session. Thank you very much.